Hello class and welcome to the Chapter 7 practice file. I want to point out before we get started that this Chapter 7 file is going to be one of two files we'll do on this content in lab. The reason that we'll do this stuff multiple times, probably even more than once, but we'll call two of them, at least in part, Chapter 7, is because this content, I think, is some of the most challenging that we're going to encounter this semester, not because it's the hardest thing we're going to do, but because logically it's going to stretch your thinking a lot further than some of the other things that we've done, and it tends to start to get a little complicated. So you're going to want to make sure that you pay attention in all of the lab sessions and in the lecture sessions, as I'm going to try to walk you through different ways to think through all of this stuff. But let's get started on the first lab. Again, this one is much more getting you used to the idea of using these index match functions or these logical functions of and, or, and not, and even this nested if function in here. It takes practice, it takes stepping back, it takes thinking about things in a different way, and learning to speak to your computer to get it to do the things that you want it to do. The index match tab is the first one in this workbook, and index match is particularly useful in business because it's a lot like nesting a VLOOKUP and an HLOOKUP together. It performs both functions in both of those functions in one function itself. So we use index and we use match together to be able to look in a data set like this one here, to be able to look in this data set for any particular cell that we want. So here we have a lot of different items and their sales for 2016. So we have quarter 1 sales, quarter 2, quarter 3, quarter 4, and we have all of these different products. Up here, we're asking you to put one function in here that will allow you to change both the item and the quarter and be able to return the right value. So let's talk about the things that we know so far in this class that would allow us to do this. One thing that we know, if we have this Olive Glow Beauty Party here and we have the data in a table that resembles this in a vertical table, we could use a VLOOKUP function. So we could do what we've been doing here and say, okay, I'm going to do a VLOOKUP. My lookup value is going to be Olive Glow Beauty Party because it's what I'm going to look up in this vertical table to try to return the quarterly result. So then my lookup value is that, and that's where I can change it. My table array for this VLOOKUP would start with the leftmost column in my table array being where the items find themselves. Now again, this is one of the downfalls of a VLOOKUP function. If you accidentally highlight the table array this way, you'll be looking for Olive Glow Beauty Party in the item number category, and the VLOOKUP has no power to look anywhere other than in the leftmost column. So if your data is set up a certain way, the VLOOKUP is great. It's very useful, it will work, but if, for example, you have item numbers or other things in the way of your table, it doesn't work as effectively. So remember when you're doing a VLOOKUP that you have to grab your lookup value in the leftmost column. Now the next argument for VLOOKUP is column index number. Right now we're looking for column quarter 1, which is in column 1, column 2, so we'll put 2. And then we have a range lookup, which is either true or false for exact or approximate match. Here we want an exact match, so we hit false, and we see that the Olive Glow Beauty Party does in fact return $5,425 as it should. So we can go through and we can change this to gift basket delivery large, and we'll look down through here, and 5101, 5101. So we're good to go with our VLOOKUP. The problem is I can't change, well, I can change this value, but it doesn't make my VLOOKUP move. The reason it doesn't make my VLOOKUP move is because of this argument here, this column index number argument. The VLOOKUP is always going to look in the second column based on the VLOOKUP that we have written. It's always going to look in the second column. So again, this works unless we were to go and insert a column in between inside our table array for our VLOOKUP. And now you'll notice that gift basket delivery large has just moved to 0 because currently there's 0 there in column 2. The column 2 isn't very flexible, and so we don't use a VLOOKUP as often as we would an index or match. Now, Having said that, let's work on the concepts of an index and a match. An index, what that function does is it returns the intersection of a row and column within a particular data set. So here, we're going to, again, we'll just leave it on gift basket delivery large, and we're going to look at the index function. The index function, when we start this index function, and it won't work unless I type equals. So equals index. Our first argument is array. In an index function, you can select your entire data table array. So your entire set of data. Because I can take give basket delivery large in an index, and I can look for its item number. It doesn't matter. I can look for item number, which is to the left of it, which we can't do with a VLOOKUP. I can look for any of these quarterly values. It doesn't matter. Index will look left, it will look right, it will look up, it will look down. The VLOOKUP doesn't have that power, making index a much more versatile function. The next argument in index is row number. So now for quarter one, I want to know what row I want to look up. So, I'm sorry, row number, not quarter one, gift basket delivery large. So I want to know which row gift basket delivery large is on. So we'll start at the top of the array that we selected. 1, 2, 3, 4, 5, 6. In this case, our row number is 6, where we find gift basket delivery large. And now the last argument in the index function is column number, and I want quarter one. So 1, 2, 3. So my index function just has an array, a row number, and a column number. It's a very simple function. And so we'll press enter and we'll get this $5,101, just like we did before. So this is great, except now I still can't do anything with my drop-down boxes because in this particular index function, I have told it to look here and go to row 6 and column 3. That's what it's always going to do. So now we're going to introduce this other function called match, and we're going to nest these two together. But first I want to show you what match does. Match takes a lookup value. For example, we'll look for gift basket delivery large because that's what we're trying to use in our index function. So it accepts a lookup value, and then it says, okay, where do you want me to look that up? Well, in this case, we want it to find this gift basket delivery large in this set of rows right here. So we know gift basket delivery large is going to be inside this set of rows right here. This is what we would have selected for our index. So we want to make sure we capture the top row as well. And we're going to see what the match function returns. The match function, if I don't put the last part, the last match type of this function, the NA value says I didn't enter enough arguments. That's what it says to me. So I can give it false or I can give it 0. Either way, it's going to tell it I want an exact match. And you'll notice it returns 6. So what the match function has done is found gift basket delivery large inside this array and told me it's at the 6th position. So this is a very, very valuable function. We'll do it again for the column value. So if I want to look up Q1 in this list of columns, and again, I can't just grab Q1 and Q through Q4. I have to grab the whole set of columns that I would have grabbed for my index array, so all 6 of these, and then tell it again I want to use type 0 or type false for an exact match and find it, and again it tells me that Q1 is in column 3. Now if I go up here and change these, you'll notice my match functions change. This is the logic behind nesting these match functions inside this index. So again, there's one match function here for row and one match function here for column. I'll go ahead and label these for you. So this is what we're going to nest inside this index function. So let's take a look at what that looks like. So now we'll start back with our index function and we'll have an open parenthesis and it'll say your first argument is index array. Again, our array is going to be the entirety of our data set because again, we can look right, left, up, or down. So we need all of it. We don't have to absolute reference here because I'm only putting this in this one box and selecting from drop downs. I'm not dragging it down. If I was going to drag it down or drag it across, I would need to absolute reference it. If you absolute reference it here, it won't hurt. I'm not going to because it's not necessary. But if you did, it wouldn't mess up your function. So the second argument again in the index is the row number, and you'll remember we did a match for the row number here and came up with a position in the data set. So we're going to nest a match function inside this index function. We're going to look for gift basket delivery medium this time, whatever this is in H2. Whatever I change this drop down box is what I want this match function to look for. The reason I choose the item name and not the quarter is because the item names are on different rows, and I'm looking for the row intersection. This seems to be a little complicated because they're in a column, but they're separated on different rows, so think about it that way. So it's always going to be this way in an index function. It's always going to be what am I looking for going up and down, and then what am I looking for going across. That's always going to be the logic, so if that helps you. Again, remember your lookup value. I should select my lookup value. My lookup value is going to be H2. Then my lookup array is going to be back in my data set. Remember, you must select from the top row to the bottom row in the entirety of the array that you selected for the index. You can't skip the header. If you skip the header, what's going to happen is match is going to count, but it's going to be off by 1 because it's not going to match your index array. So be really careful that you start and end in the same place that you did for your index array. Our last part is match type. We can type 0 or false, again, because we want an exact match. False is the argument inside of VLOOKUP for an exact match. It works inside the match function as well. 0 is what a computer recognizes as false, so you'll see both 0 or false in this argument. The last argument in this index function is column number, and again, like I said, we're going to use a match function to find this column number as well. Here we will use I1 as our lookup value, or the quarter. For our array, our lookup array, we will select all of the column headers, again, because we selected them all in our index array. And again, an exact match, a 0 or a false here. I close both sets of parentheses, one for my match and one for my index, and then press enter. Now, let me unhighlight this because that's not the one that we're looking at anymore. Gift basket delivery medium Q3. Gift basket delivery medium Q3. You'll notice the two values match. If I change to Olive Glow Beauty Party Q3, I end up here. If I change to Q1, I end up here. And you'll notice that it moves, and it's much more versatile than the VLOOKUP. So the index match we will do every time we're in lab for the rest of the semester. It's a very important function. I understand that it's difficult because it is our first nested function as well as a complicated logical function. But once you realize what the match functions are doing, it begins to make sense. So just bear with me as we go through it. Now let's move to our and, or, and not tab. Our and, or, and not tab are going to talk about different kinds of logical functions that we haven't done before as we move into this. So we've talked about logical functions being an if statement. Now we're going to talk about a computer language that is going to sound sort of foreign to you. What I want to point out is here the logic of and, the logic of or, and the logic of not are very basic to a computer. And is going to mean all. To a computer, in Excel 2016-2019, you can put 30 logical functions inside an and or an or. It used to be more than that. They've decided not to do that, but that's okay. So you can do 30, up to 30 logical functions. And logic means all. So and to a computer equals all. It means everything in there is going to be true. Or to a computer means one of these. So or is going to say if I have 30 arguments, at least one of these is true. Both of these are what we call Boolean. They spit out a Boolean data type. A Boolean data type means it's either going to say something is true or false. Not the word true or false, but the value to a computer, the actual true or false. Either all of these statements are true or they are all false, one or the other. This also can be represented by 1 or 0 to a computer. But again, that's what the computer is trying to do, and that's just some basic information about what's happening here. So let's read our directions. Our directions say, please show if each sales rep met or did not meet their individual sales goal. Please use an if function in column D, an and function in column E, an or function in column F, and in column G, you will need an if function as well as an or function. Let's see. We're not going to do that. In column G, we're going to use a not function as well as an or function. So I think I corrected that in yours. Hopefully I did. But in column G, we're going to use a not and an or. So we could use an if, but it becomes a really wicked, complicated statement if we use an if. So we'll just use the basic one and just use the not. So here, for our sales goals achieved, it asks us to use an if statement. You guys can do an if statement. You know what it means. First argument is logical test, meaning did Jordan Hinton, is his sales greater than or equal to his sales goal? We're going to want to absolute reference his sales goal, and we're going to want to put greater than or equal to, not greater than or plus, because that's going to be really weird. If that is true, we want this to say goal met. If it's not true, we're going to say did not meet, for did not meet the goal. And again, I'm putting these in quotation marks because they're text, and I want this to return text. So Jordan Hinton did not meet his goal, and we can just double click and copy this down and see that Chiquita Walsh did meet their goal, so we're good to go. Gold producer. Gold producers met their sales goal and their new client goal. So here's a new function for you. We're going to use the function and. When you type equals and you open this up, you get two logical arguments showing. You see the ellipsis here, which means that you can have more. Again, you can go up to 30. We're going to do 2 to start out with to be simple. And means that both of these things need to be true. So they need to have met their sales goal and their new client goal. So again, our first logical test is going to be, is B15 greater than or equal to their sales goal? And we're going to want to absolute reference that. Our second argument is going to be just as basic. It's going to be, is their new client goal greater than or equal to their goal? Their new clients that they brought in, is that greater than or equal to their actual goal? So we'll do both of those arguments. And again, this and is going to check to see if both of those are true. And is going to mean that all of them have to be true. And it's going to return either true or false. You'll see that one is false. And you'll see as we go down and we look right here, all of them are false. So even back where the sales goal is met with Chiquita Walsh, the new client goal isn't met, so still false. So we'll look down through here to see if we can find a true one. And we'll find Nehru Bowers, and Nehru has almost $1 million in sales and 30 new clients. That is in fact a gold producer. So we know our formula is working. Our silver producer, they either met their sales goal or they met their new client goal. So here, the directions tell us what to use, but we would know to use an or function because we just need one of these two things to be true. So we'll type equals or, and again, we get the two options for logical functions, and again, can do up to 30. So here, sales goal greater than or equal to, or sales greater than or equal to the goal, and new clients greater than or equal to the goal. And remember to always absolute reference the goals, because if you don't, as you copy them down, it will move and it will mess up your function. So B15 greater than or equal to B12, C15 greater than or equal to B13, and we'll get the or. So now, again, Jordan Hinton, he's just not making it this time, which is okay. But Lila Douglas, she met her new client goal, but she didn't meet her sales goal, so it shows us a true. Again, it's going to show us a true down here, even in Nehru Bowers, because what's happening is Nehru Bowers met both goals, but the or is checking to see that at least one are true. So it's possible to have two trues in this situation, just like it is to have two falses. Lastly, our rookie producer, we're going to use a not function. A not function logically can only have one argument, so we're going to have to nest a function inside of this not in order to be able to capture both of the options that we want to capture. If the rookie producer has met no goals, we need them to be the opposite of the silver producer, because the silver producer has met at least one of the goals. And somebody who meets at least one of the goals, the opposite of that to a computer is someone who has met none of the goals. So we will take the opposite of the or statement. So here we will nest inside an or statement that says exactly the same thing. 2016 sales are greater than or equal to the goal. And then the new clients are greater than or equal to the new client goal. So you'll notice we're doing the same functions or the same logical arguments over and over again. We're just changing the functions that they're inside to get different logic from the computer. So again, let's take a look. This has or, B15 is greater than the goal, and the new clients are greater than this goal. So those are the two logical arguments. So this or statement is going to give us either true or false. So it's going to give us true. The or statement will give us true if one of these two things are true. So we know for Jordan Hinton, this silver producer, the or part of this statement is going to spit out false. Well, this not is going to reverse whatever the or statement spits out. So the not is going to give us whatever is the silver producer, whatever the opposite of that is. So any place that we have a false in silver producer, which is what we have captured inside our or statement, any place the silver producer is false, the rookie producer should be true. And logically, that makes sense because if one of these things is true, again, is the complete opposite to the computer of none of them being true. So you'll notice all the trues are false and the falses are true, and that's how this works. Again, I know the not statement is super confusing. There are many ways to accomplish this. This worksheet is designed for you to practice these and or not functions, but you could do this particular column again with a lot of different things. For example, I could use an and. Since I know that and logic tells me that everything that I put inside here has to be true, I could say equals and gold producer equals false, not in quotation marks because I want the value false, not the word, and silver producer equals false. If both of those things are false, I want this to display true. I could use this just like an and, right? This is the and version of rookie. Let's see. I'll make it look like this. So I'll format paint that to look just like this and give you an extra column here. So that's the and version of the rookie producer. So there's always more than one way to get to the answer. The not is just the reverse logic. So hopefully that makes sense. Now let's look at this nested if. This nested if looks a lot like data that we've been dealing with over and over and over again. We've been calculating a lot of bonuses. This is a good way to logically think through if logic. So this makes sense in a business context, which is what we're going for here. So it says, please calculate the bonus to be paid to the employees based on years of service. We've seen this before, right? But before, we've only seen it with two options. Here we have three options. Please give employees with more than 10 years of service a $5,000 bonus, 5 to 10 years a $3,000 bonus, and less than 5 years a $1,000 bonus. So we have three options. When we have three options, when we're doing a nested if statement, we have to type the function if one time less than we have options. So if we have three options, we're going to have two nested ifs in this equation. So let's figure it out. We've got to figure out years of service first in order to be able to capture the bonuses. So to get today's date, we just type today equals today in this box. Years of service, we've learned, is going to be equals, open parentheses, today's date minus their hire date, which is going to give us the number of days between today and their hire date. Again, we start with today because it's the bigger number, it's later. So we start with it to do subtraction, go back to their hire date, and we can divide this by 365 and get 17.2. That's one way to do it. Now I'm going to teach you a function way to get it. So we can do a function as well. We call that function year frac for the fraction of the year that we want to know. And year frac has two arguments, and well, three really, but basis is optional. So two arguments that we'll use. And it says start date. So start date is the opposite logic of what we just did. Start date means the earlier of the two dates. So here the start date is going to be the hire date, and the end date is going to be today. I'm going to absolute reference the today one. I didn't do it a second ago because I knew I wasn't going to keep it. But now I know I'm going to keep it, so I want to absolute reference today, and you'll see the same 17.2 come up. So an easier way to get years of service. Now, our bonus to be paid requires three options, and I'm all about getting you to walk me through in words what's going to happen. I know that you could tell me that employees that have been here 10 years are going to get a $5,000 bonus. Employees here between 5 and 10 years are going to get a $3,000 bonus. And less than 5 years, a $1,000 bonus. Here's the problem. Excel's not going to accept this word between. So when you walk me through this logic, Excel doesn't compute very well this word between. So what we're going to do is create a nested if statement, and we're going to remember that computers read from left to right. They read one thing at a time, and then they drop out. So this is, I've said that to you before, but it hasn't necessarily made sense. It's going to start to make sense here. You've heard me say before that they read from left to right, and you're like, yeah, I get it. So do we all. But here's where it starts to come into play. So we're going to start with an if statement. And here we're going to start with a logical test. And when we're doing nested if statements, it's really sort of something that you have to think about before you start typing. You're either going to want to start at the top of your range and go down, or start at the lower end of your range and go up. I typically start at the top of my range and go down. It's the way that logically my brain works. But you can do it either way. Neither one is wrong. And you just have to stick with one. Pick one and stick with it. So here we're going to do it my way. So we're going to say if years of service is greater than 10. So if the years of service of this person is greater than 10, if they've been here more than 10 years, I want them to get a $5,000 bonus. So I know my value of true is 5,000. What's my value if false? Well, if we're having a conversation about this and I say, okay, if this person's been here 10 years, what kind of bonus do they get? And you say 5,000. And then I say, okay, well, what if they've been here less than 10 years? Well, it depends. Right? So if you find yourself saying it depends, which means I still have more than one option to go, I'm just going to type the word if again. Because right now, if they haven't been here more than 10 years, it depends on what happens. So now we'll start with the next part of this function. So we'll have years of service here, and we're going to say greater than or equal to this time, greater than or equal to 5. So what this part of the function is going to do is say, okay, I know that they haven't been here 10 years, because if they'd been here 10 years, I would have given them a $5,000 bonus. So I know they haven't been here 10 years. That's the only reason the computer is still reading. So now it says, have they been here equal to or greater than 5 years? If that's true, that means that somewhere between 5 and 10, they're going to get a $3,000 bonus. And now I'm left with, okay, we've decided they haven't been here longer than 10. They haven't been here between 5 and 10. So what's left? I don't have an it depends anymore. Everyone else gets a $1,000 bonus. So that's the value if false in the second if statement. You've got to close the parentheses for both if statements, and off you go. So let's check and see if it worked. 5.1 years, that should be 3,000. 3.6 years, that should be 1,000, and we're off and running. So again, nested if statements aren't complicated if you can logically think your way through them. So we're going to continue to practice. Next, we have database functions. And database functions are pretty cool because they take the place of filtering. They take the place of count if and sum if. They take the place of pivot tables. So they're one way to get to a variety of answers. And here we have a variety of things we want to know. Again, we have all of this data over here. You've seen it lots of times, right? It's the same data about the people that we've been talking about. And it has salary information, hire date information. You've seen the data. You're accustomed to it. You understand what it is. Just like if you were in a business, you'd be using the same formatted data over and over again. We're doing that a lot in here to bring consistency. So I know you've seen this data before, but we're going to do something different with it now. So here we want to say, please calculate the sum of all employee salaries in the IT department. The way database functions work is you have a database and you have what's called criteria rows. The criteria rows have the same headers as your actual database, and then below them you can put criteria. So here I have a couple of drop-down boxes where you can select a department, or you can select a status of person, hourly, part-time, full-time, whatever you want to select. But these are criteria rows, so this is going to sum based on some certain criteria, some average count or whatever. So we're going to use these as criteria rows. So here we want to calculate the sum of all employee salaries in the IT department. So the function name, I've given it to you right here, is dsum for database sum. The database is going to be all of this data over here. I select all the column headings. On my computer, I'm going to hit Command-Shift-Down. If you're using a PC, you can hit Control-Shift-Down to capture all of the data in the database. I'm not sure what my computer has done. You're going to want to do A1 to I-742, and then you're going to press comma. Probably what just happened is I decided to scroll up before pressing my comma, but you're not going to want to do that. You're going to want to make sure that you put the comma before you start scrolling back up, because that's likely what just messed mine up. But anyway, our next argument is field. So field means what is it that you want me to sum? Like what part of this database do you want me to sum? Well, here we want them to sum this function to sum salaries. So I just click on the column header of salaries. Just click on F1. My criteria is going to be the department IT. So what the computer is doing is it's looking for my criteria. So it's going over here and it's looking in department, and any place it finds IT, it's going to sum whatever's in the salary column. It's basically a sum if, but it's just called a database function. So it's going to sum and it's going to get to this. Works the same way. The same arguments appear in all of these functions, so we'll do them rather quickly. The d-average is going to average whatever I put in here. Again, I can click on job rating. I can hit Command-Shift-Left, Command-Shift-Down, and then press comma before I start scrolling back up. Pressing comma changes the argument in my function, so no matter what I click on now, it won't affect my database. And I want the average function, or the average salary for all the full-time people. So my criteria, my field, again, that I want to average is going to be salary. So I click on F1. And then my criteria this time is going to be I want their status to be full-time. So again, the computer is going to look in this status row. It's going to find all the full-time people and it's going to average their salary. That's what the computer is doing. So it'll find the average. This isn't going to show up in a format that I like to look at it in, so I'm just going to hit comma to give me a regular number with decimal places. It says count. Please calculate how many employees have salaries over 70,000. So here we'll do database count. And our database, again, click on job rating, Command-Shift-Left, Command-Shift-Down, comma to freeze my database. Scroll all the way back up to the top. Now I want to know the count of the salaries of employees over 70,000. So I still want it to count in the salary row. And I want it to count the salaries that are over 70,000. So for criteria here, I'm going to select salary, and I'm going to select this blank box. I'm going to select the blank box because I need a criteria. There's not one there. I haven't already built in a drop-down box for you. But you're going to want to select somewhere that you can give it the criteria. So you want to select salary and the criteria box there and press enter. Now you'll notice you get 741. If you click on F, it's going to tell you there are 742 rows in that column. That includes the column header. So there are, in fact, 741 values in that row, values being numbers. And that's what count does. It counts the number of values. So it doesn't count that word salary, just like it shouldn't. It's only counting the values. But I only want to know the ones over 70,000. So up here in this box that I selected as criteria, let's put the criteria. Let's say greater than 70,000. When you put the criteria in there, all you have to do is change the criteria and the function updates itself. Dmax, please show the maximum full-time salary. So Dmax, same thing. We'll grab our database, Command-Shift-Left, Command-Shift-Down, comma, to get me in a new argument. Again, I want salaries and I want full-time employees. So I'll select F1 for my field and my criteria to be status full-time. Close my parentheses and hit enter. So I get the maximum salary. The minimum salary is the same. Again, database, Command-Shift over, Command-Shift down, comma. My field is again going to be salary. I want the minimum salary, so salary, F1. And I want the status to be full-time. Same thing. Told you it's going to be a lot of arguments. You've entered too few arguments for this function. What have I done? Oh, okay. So here's what I did. Instead of a comma after my database range, I put period. Period won't work, so it didn't separate my arguments. There we go, 22,000. Decount A is going to count the non-blank cells. So decount counts the values. Decount A is going to count the non-blank cells. So here I want to know how many employees have benefits. Command Shift left, Command Shift down. I know where my database lies, but let's take a second to think about our field and our criteria. So if I want to count how many people have benefits, I'm going to want to count the non-blank cells in the benefits column. So now instead of F1, it is D1. And I want to know this for only the full-time status people. So again, the computer is going to look in status. It's going to find all the people that are full-time, and then it's going to count how many of them have something in the benefits column, the non-blank cells. That's what it's going to do, which is what I want it to do, and we're in business. Now, all of that seems relatively easy. Once you realize that these are criteria rows and all the data is over here, it seems pretty easy to use these database functions. They're very helpful. They take the place of filtering. So I could have gone over and I could have filtered to all the full-time employees and then counted myself. I could have done that. But these database functions, this way I don't have to filter. I don't have to hide some of my data. I don't have to do anything like that. I can just create these functions to do it for me. I also could do a sum if function, which we will learn later. So I sum if the job status equals full-time, and I could type all that in. But doing the sum ifs and doing the filtering mean I have to do the work over and over again if I simply want to change the department. So if I want to, instead of find the IT department's salary, let's say I want to find creative salary. All I have to do is change these drop-down boxes from one thing to another to change these database functions. It's not that easy with filtering or with sum if or count if. So without nesting in functions inside, which I could also do. But let's look what happens if I change. A lot of these have to do with full-time employees. If I change to contract employees, you'll notice all of the numbers update and I don't have to do any more work. So that's the usefulness of these. Our last tab for today is loan amortization. I told you loan amortization and loans are really important to me. They're really important in your finance classes. They're really important in your college career. They're also really important in your life. So when you go out and you buy a car, you buy a house, it's important to know the kind of interest rate that you get affects how much money you pay in interest. You're going to pay in principal the actual amount of your loan. That's always what's going to happen. But I'd like for you to know how much money you're paying in interest to finance something. So that's really important. So this says, please find the payment amount for each payment period, split each payment into interest and principal, then find the total interest paid per period, the total principal paid, and whatever principal is remaining. So this is what's called a loan amortization table. If you're an accounting major or finance major, you will live in these for a while, for some portion of your life. But all of you will need to use them at some point when you buy a car, buy a house, buy something that you have to finance. So there is a method to my madness of teaching you this. It applies to all of us. First, let's find the payment amount. We're going to do equals, and we're going to do minus, and we're going to do payment. We know to put the minus sign in front of a payment function. We've already learned that one, so we know that is coming up. First argument of payment function, as we well know, is rate. Our rate here is an APR, an annual percentage rate. So that means if I have monthly payments, which I do, I have to divide by 12. My number of payments is going to be right there. It says total periods. So my number of payments is there. My present value is right there, $350,000. Again, I could ask you to subtract a down payment. We don't have one here, but that would be part of that present value. I don't need to absolute reference any of these. I'm not dragging them anywhere, so I can just simply calculate my payment. My monthly payment on a $350,000 loan at 10.25% interest is $16,191. This is why people pay monthly, and they have loans for houses that stretch across 30 years. Watch the payment change, $3,000, as I go to a 30-year mortgage instead of a 2-year mortgage. Can you imagine making monthly payments of $16,000? That sounds scary, but that's what we have going here. So again, showing you how dynamic Excel is, I can just change them and it changes my monthly payment. So I go back to 24, which is what this is asking because we have 24 payments. Again, I could do this loan amortization schedule just as easily with 360 payments, but I want you to be able to see it all on one screen, so I did a smaller one. To find the interest portion of our payment, it's its own separate function in Excel. It is equals I PMT for interest payment. You'll see the arguments are very similar to the regular payment arguments, but there are a couple of exceptions. We'll start with rate. Our rate, we're going to do 10.25%. We're going to freeze it because we are going to drag it down now, but it's always going to be that 10.25% divided by 12. It's an annual percentage rate. The second argument in this function is the one that's different from the payment function, and it says period. Which period am I currently in? Well, I'm currently in period 1. So I'm going to select D4 right there, the period 1 cell. I want the period to change as I drag it down, so I will not absolute reference D4. In period means the number of periods. You know that one. You recognize it. You know it well. So we'll freeze D4. That one stays there. Present value. You know that one. We're going to do the 350,000. Lock it down. Absolute reference it so it doesn't move. My B4 is not absolute referenced. It's mixed referenced. Hold on. Let me fix it. There we go. And then fair value and type we know are optional arguments, so we will ignore them. So here we have a negative one. Again, I did this to show you that all the payment type functions return negative numbers. I'm going to put a negative sign outside of all of them because I don't want any of them returning negative numbers. So you see, as we move down these 24 periods, we pay less in interest each period. We're going to pay more in principal to make up the difference, but that's how compounding interest payment schedules work. Loan amortization schedules, that's how they work. So what part of that payment is principal? So equals negative. And here our function is called PMT for principal payment. Again, we have rate, which we need to stay the same as we drag it down. So we'll absolute reference divided by 12. Again, the second argument is period. So it wants to know which period are you in. So I can tell you the principal part of that particular period's payment. So that's going to be D4, that one right there. And as I drag it down, I'm going to want that one to change. So I'm not going to absolute reference it. Number of periods, you know, is 24. We'll lock that down. Present value, you know, so we will lock that one down. Again, I have two optional arguments out here, fair value and type. You can put 0 for both of them. We're just doing the standard type. In your finance classes, you likely will have future values. You likely will have annuity due and ordinary annuity. I don't care. For the purposes of this class, we will keep the defaults, so you don't have to do anything to those. And then you can double click the VIL handle to copy it down. Here's what I want you to know. When you get to this principal column, if you sum all of these values together and you look down here, they should sum to $350,000. That's the principal that you're paying. It should match your present value. That's one way to check to make sure you've done this correctly. The other way to check is to take any particular period and highlight both the interest and the principal payment. That should equal your payment amount. So any one payment period should equal this $16,191.14, and it does. So now we have total interest paid and then total principal paid. All that is asking you is how much interest have I paid to date? So equals minus, and this is going to be cumulative interest. Maybe. Yeah. Cumulative interest payment. CUM for cumulative, I for interest, payment for payment. So here we'll have rate. All of these arguments are the same. As you know, for a lot of these payment functions, we'll have B3 divided by 12. Number of periods is going to be 24. NPER is number of periods in all of these functions, so we'll lock that down. Present value, we know, is $350,000. We'll lock that down. Here we get to the different parts of this argument. Here we say start period and end period. Well, the start period is 1. The start period is always going to be 1 because that's where it starts. The payments start in period 1. So the start period is 1 and is going to remain 1. So we'll lock it down in D4. The end period, however, is going to be whatever period we happen to currently be in. So in this particular row, it's still period 1, but it's D4. But as we drag it down, you're going to want the end period to move, and I'll show you that in a second. And then we can close. Oh, nope, can't do this one. This one actually has to have the last argument for type. We'll do type 0. Because we're just basic in this class. Now, up until now, all through this worksheet, I've been able to double click on this green fill handle and it's copied down and everything has worked beautifully. I did this on purpose to remind you that the only reason double-clicking on this fill handle works is because there's data directly to the left. So here I inserted this fancy blank column so that I couldn't do it, so I would remind you, if your double-click doesn't work, you just grab the fill handle and drag it down. So what's happening here is the total interest paid, let's say for the first 3 periods, is $8,629. For period 3, total interest paid, $8,629.50. So what it's doing is calculating the total interest that we've paid up until this point. It's pretty useful. We'll do total principal paid as well. So equals minus CUM for cumulative, this time PRINC for principal. And the arguments again are the same. I'll do them quickly. Rate is going to be 10.25% divided by 12. Number of periods is going to be 24. Again, I'm absolute referencing everything that's over in my input cells. Present value, 350,000. Start period, again, I will absolute reference start period 1 because start period is always going to be 1, but end period is not always going to be 1. So again, I'll click D4 at this point, but I'm not going to absolute reference that, and we'll do type 0 for basic again. So now we can copy and paste it down. You'll know if it gets to total principal paid 350,000 that you've done it correctly. Remaining principal is the easiest thing on this sheet. It's simply going to be the present value. We're going to want to freeze that because it's in the input box over here. Freeze that present value minus the total principal paid. A million ways to get that. That's the easiest one. So principal remaining is the present value minus the total principal currently paid, and it should go to 0, and it does. So remaining principal at the end of our loan is obviously 0 because we have paid off the entirety of the loan, and that's how you make a loan amortization table. We're going to work with them over and over and over again. You're going to become very familiar with these functions, but as you go across these functions, interest payment, principal payment, cumulative interest payment, cumulative principal are very important. So there's 5 functions on this page that you need to pay attention to, 5 payment functions. They all spit out negative numbers. There are more payment functions we're going to learn. Upcoming, we have rate and present value functions that we will learn as well. But for now, this is a good place to start.